So question number 12. A gas phase reaction A goes to 4B, this is the reaction, is performed inside a batch reactor. Initially 2 moles of A was charged into the reactor. So Na naught is equal to 2 moles. The pressure was 5 bar. Initial pressure, let's say we have P1 is the initial pressure, that is 5 bar. Assuming the volume of the reactor is kept constant throughout the process, determine how long it will take the reactor pressure to reach 10 bar. So P2 is equal to 10 bar and the rate constant K is equal to 0.1 minute minus 1. So in here rate constant, if you see the units, whenever the rate constant is per unit time, it is first order reaction. Okay, so for the first order reaction, rate is equal to minus K E A. Okay, so let's start from the general equation for the batch reactor, that is dNA by dt is equal to R multiplied by V. Okay, so dNA by dt is equal to R. What is R? That is minus K Ca multiplied by V, and we know that Ca concentration is equal to moles over volume. Just paste the value of Ca in here, so it will be dNA by dt is equal to minus K Ca is equal to Na by V multiplied by V. Volume will be cancelled out and we will be left with dNA by dt is equal to minus K N A. To integrate this one, take Na to the other side, it will be equal to minus Kt, integration of both sides, and it will be, as it is 1 over Na, so it will be natural log of Na to the limits Na naught initial moles final moles is equal to minus K T 0 to T, and once you apply the limits, it will be upper limit minus lower limit is equal to minus K T, and the natural log can be written in terms of natural log of Na over Na naught is equal to minus K T. Okay, so Na naught is given, K is given, we need to calculate Na, number of moles of A at any time. Okay, so for this one we have to do some work. As we know, the values of pressure, initial pressure and final pressure is given, and from general gas equation, ideal gas equation, we know that PV is equal to nRT. Okay, so in the question only pressure is changing and along with it number of moles will be changed, so we can assume that volume and temperature is constant, so we can write it like V over T is equal to nR by P. Okay, and V over T is constant, so we can write it like constant. So it can also be written as N1 R by P1 is equal to N2 R by P2. R will be cancelled out and the final equation will be N1 P1 is equal to N2 over P2. So we need to take care here. So N1 is the total moles. Total moles at T is equal to 0 when the reaction is not started. So as there are two reactants A and B, N1 at any time will be equal to Na plus Nb. Okay, so at time t is equal to 0, what is Na? Na is 2 moles. Plus at time t is equal to 0, what is the moles of B? When the reaction is not started, moles of B is equal to 0 and N1, so N1 will be equal to 2. Okay, so in for this equation, this one is given, P1 is also given, P2 is also given. Okay, but in this question we need moles of A. Okay, so for N2, N2 will be equal to Na plus Nb at any time. Okay, so I will move up here. So N2 is equal to Na plus Nb. Okay, so let's say at any time X is equal to moles of A consumed. Okay, so Na will be N2 is equal to Na will be 2 minus X. Okay, so at any time Na will be equal to 2 minus X, and Nb, if X moles are reacted, if 1 mole is reacted, 4 mole of B is produced. Okay, so if X moles are reacted, 4 moles of B is produced. So N2 will be equal to 2 plus 3X. So paste, now we have N2 as well. Paste all values in here and 1. I am putting values in this equation. So N1 is 2 divided by P1 is 5 bar. N2 is this one, 2 plus 3X divided by 10 bar. From here you can calculate the value of X, and X will be equal to 2 by 3 and it will be equal to 0.667. So X are the moles reacted and Na will be equal to 2 minus X, 2 minus 0.667, and Na will be equal to 1.333. Now put the values in here. Natural log of 1.333 divided initial moles are 2 is equal to K is minus 0.1 into T, and once you solve it, T will be equal to 4.05 minutes. So this question is also complete.